All right, welcome to the AAPT Coffee Hour. And tonight we have a great conversation about building a yes space in our introductory physics classrooms. And our speaker tonight, or our host, our conversation leader, is Dr. Katie Ansell from University of Illinois. And I will turn it over to her and let her introduce herself and start the conversation off.
All right, so yeah, hello. I'm excited to see so many people here today. So my plan today is I'm going to start off by bringing up an idea, which actually I borrowed from parenting, oh, I got a network connection is unstable, so we'll see what happens. Am I freezing at all?
You're good.
I'm good. All right. So I want to highlight that example, talk a little bit about it, and I actually want to spend a little time getting into something that maybe makes us feel a little uncomfortable as instructors and embrace the way that this discomfort can be a flag for us as an opportunity to try something different. Let me go ahead and I guess get my slides going, because I find that having visual cues really help me focus, and hopefully they'll do the same for you. But my goal is to not spend the whole time talking at you, but really to get the opportunity for us to talk with each other about this. So let me do the thing. Let's see if I can figure it out. All right, you still have me with the screen share? I'm not used to this. Excellent, cool. So nominally what I have titled this talk is Reimagining the Introductory Physics Classroom as a Yes Space. And I will say that a lot of the work that I've done up to this point has been situated in physics labs, where there's a lot of opportunity for flexibility and freedom. But I've also been getting more into large lectures, and I do tend to, at the University of Illinois, our service courses serve, the small courses serve upwards of 200 students. So I've been having to think about a lot of these questions at scale and how to introduce flexibility and creativity in these classes where we have to just kind of mass produce physics education. And so I don't need to spend a lot of time on this slide because I think Mark really covered it, but I encourage you in this space today to join as a participant if you feel comfortable and we stay under the limit. We'll do the dance as we need to. And please talk with each other and share resources in the chat. I will remind you that the chat messages do persist, so just something to keep in mind as you think about what you put in there. And my goal is I'll start with this presentation, but I hopefully we'll have at least half of this time be a conversation. So I'd like to start with two claims and a conflict. And so first claim I'm going to make is coming from kind of a traditional American school background and coming up through traditional academic, institutional structures. We hold this idea that we want our students to demonstrate creativity, independence, and mastery of the content that we're teaching them. So that's kind of what we want students coming out of our classes to have. But we also come through a culture of academic instruction norms that there's a lot of things going on with the norms of how we teach, but one I want to really point out is that we're really used to classrooms where the instructor is in power, they are in control, they are they're giving knowledge, they are the center of attention. Just like right now, I am in control, and you can be a benevolent dictator, but you're still the dictator of the room in the models that many of us come up through. Side note, if you're interested in more conversation about this and rethinking it, I really recommend Bell Hooks. Teaching to Transgress is a fantastic and challenging book. And there's a PDF version. I'll have to make sure the link gets in the chat when I get a moment. But if you Google it, that's the first thing that comes up. But what I have found, and I think what many of us have found, is that there's this conflict between our enculturation to control our students, to really lock things down, and their creativity and independence and ownership. And so there's a lot of times when I talk to peers, colleagues, that are really frustrated because they show their students how to do it. They tell them how to do it. They exert more and more control, and yet their students aren't more creative, which, in some ways is not super surprising. So my goal today is to, in this presentation part, is to offer a framework to help us kind of rethink our classroom practices in a way that encourages learning through freedom in the classroom or through our assignments that we give. And just kind of like a feelings check here, a gut check, is that your first reaction maybe with some of the things that I say or some of the things I try to bring up in the conversation is that this won't work. This will not work for me. There's no way. This is a normal reaction. We're used to a certain system and the way that things work, and we're used to being in control. And so what I'm going to say is not ignore your discomfort, but I think that this is something that we can hold. And, for now, we're going to hold it. I'm just saying you may feel a little uncomfortable. If you don't, great. I love it. But I'm going to take us through an example of sort of this kind of thinking, this like discomfort and fear reaction, and maybe another way that we can remap it to something that is more productive and brings more change in our instruction. So when I talk to colleagues, many of whom have been teaching for a really long time, I hear a lot of statements along the lines of my students can't. So, my students don't know how to use their data visualization tools. Clearly, I'm a labs person. So, like the control response is to make choices for them, give them information, take control out of their hands by choosing their tools, giving them guidebooks with all the step-by-step instructions, automate the process so they don't have to think about it. When students mix things up, maybe we need to tell them more. Ask them to practice more, which, practice is good. I'm not saying practice is bad. Or, students can't apply things. So I'm going to give more examples. I'm going to give more and more and more. But I think that I encourage you to start thinking about how these challenges can be reframed as learning opportunities. So, where students don't know how to use data visualization tools, maybe we need to let them sit with it and figure out a way to do this and think about whether it's working or not. Or, if they're always mixing two things up, instead of telling them again and again that they're different, maybe they need to come up with an explanation for how things are different or write a guide to themselves for how to tell them apart. Or, if we're worried that students can't apply things to new situations, maybe they need to understand the tools in a more nuanced way, and maybe they need more opportunities to try without a high risk. So these are maybe some ways to think about our classrooms. I actually have found that my teaching has been really influenced by my parenting. I have a 3-year-old, and she is wonderful and challenging. And an idea that I've stumbled upon as I have investigated parenting much in the same way that I have investigated educating is this idea of a yes space, which is an idea that was, so this is from Reimagining, R-I-E. I've forgotten what the acronym stands for, but it's this idea of even for children and babies, treating them like people who deserve respect. And so this idea is developed by Magda Gerber, and the term has been coined by Janet Lansbury. And the idea of a yes space for small children, for babies, for example, is having an enclosed space where you can put a baby, they can explore safely, and we don't, as a parent or an adult, you don't have to jump in all the time to correct them or say no. And so the key features of this kind of space are that the child is safe and they feel safe. And then there are things present in the space that are appropriate to their abilities and to their development. So that's for kids. As far as a classroom, our students are also whole people who deserve respect. And so when we think about having a yes space in the classroom, this is kind of what I see as key. First is that students can be free to explore and invent without us needing to constantly correct or interrupt them. That doesn't mean we always, throw everything open all the time, but, spaces to explore and invent without correction and interruption. Safety, that the students feel safe to explore, meaning there's not going to be consequences for mistakes. Maybe literally they're safe. And as instructors, we trust that meaningful progress will occur. and that the tasks that we give our students are appropriate to their skill levels and previous experience. So a yes space is not throwing everything wide open and just saying, let knowledge happen spontaneously, but it is, I think, sort of a curated space where students can have freedom, they can explore, and make progress without being overwhelmed by the full spectrum of choice that could be available. So a framework that can move us from kind of this control mindset to yes. I think that there are different ways that you can do this, but for me, I find that it's really helpful to start by noticing what I call the no's. So like that, those things where I have a knee-jerk reaction and I say, I need to make my students do this, or they can't do this, or this isn't possible. So actually that's what I have here. So, things like, how do I make my students do something? My students can't do this. My students won't do this. Those can be a flag for us to notice that we're thinking in a controlling way. And this gives us an opportunity to evaluate the space that we're setting. So the figurative or literal space. We can notice that we have some kind of expectation that our students aren't meeting, and whose fault it is, I'm not worried about at this point. But noticing this gives us a chance to also interrogate it. So we can ask questions like, well, what is this expectation really valuing? Does it have to happen this way? And is this expectation, the way I'm trying to carry out, actually respectful to my students? And then I think kind of part of this movement toward yes, then, is to balance the boundaries, the expectations that we have, the objectives that we've set for our class with respect for our students. And so there are opportunities, or we should maybe seek out opportunities to co-construct our classroom spaces so that students get a little more control. Oh, I guess that was the end of that slide. Sorry. So maybe the thought is we can start making spaces together with our students that get us to the learning objectives, but also let our students have a hand in getting there. So I have a couple examples, and then I will take us to conversation. So I want to talk first about an example of moving toward yes, as far as getting students to practice new skills and ideas, because I think this is one that as physics instructors is very near and dear to our hearts, because we say, here's a thing, try it, eventually master it. So maybe one of these questions could be like, why won't my students answer or ask questions in class? I show them the material. I say, any questions? No answer. Well, let's start by noticing the no's. In a case like this, we're asking questions or asking for questions. Students are silent. There's a lot going on here. I know that a lot of this has to do with culture setting. But one of the things that we can think when this happens is that, our students aren't thinking, they don't want to participate. Certainly there is a lot going on, especially during this pandemic, that will impact participation. But this gives us the opportunity to evaluate the space. So why do we ask questions? Well, we want students to practice. We want to make sure our students are paying attention. We want to get some kind of feedback from our audience. Well, but students are quiet for various reasons. Maybe they're tired. Maybe they're still figuring it out. Maybe they still haven't even figured it out to know what their question is. And of course, the perennial favorite, they might be afraid of being wrong, which I think is very common in physics classes because, being wrong once often feels like being wrong forever. So how do we balance boundaries with respect? I've found that one of the big pieces for this kind of classroom interaction is really leaning on consistent messaging that learning is a process, both in terms of what you practice and what you preach. So we can frame our questions as practice. So one of the things that I do, you don't have to do this, but one of the choices that I've made for my lecturing is that I don't ask questions that I expect most of the class will get wrong. And I don't ask questions that students don't have the information to answer. So I don't want to ask what do you think is going to happen unless the students already have some kind of theory that will allow them to make a prediction. I don't want them to be testing themselves. I want them to be testing their physics knowledge, which are distinct, I think. I want to make that point. So an example from a course that I taught last semester, Physics 102, is using anonymous polling as a practice, as a way for students to practice. This is in a algebra-based second semester introductory course with a lot of life sciences students, many of whom feel very threatened by physics and have had messaging already that, you know, physics is for smart people and other problematic messages. And so a practice that I started doing is to introduce a new topic, then use an anonymous poll, you know, after introducing the topic, to sort of bring in this like, what's next, or how do we know this kind of question. I always framed it as, here's a chance to try. And of course, the anonymity is nice because it makes the participation feel better or safer, you know. So for example, one of the things, a sequence of poll questions that I've used have been for practicing the right-hand rule, because that's notoriously difficult to somehow suddenly start using 3 dimensions. And so I'm not going to read through these whole vectors. I think most of us are familiar with the right-hand rule, but after introducing the right-hand rule, and you know, the structure for in and out of the screen, we look at an application. And what I do with my class is, first we do it together, no poll question. We bring in the magnet. We say, which direction are the electrons going to be deflected? So first time is do it together. Students get to try. Zero stakes. Next time I ask them a poll question where there's a small variation. We practice it again. They get another variation. We practice it again, and so on. So what's happening here is that students practice with guidance. They get to practice on their own and get feedback, and then they get another chance to practice. And what I notice is that more students get it right each time. And then if they don't get all the way there, they still have more opportunities to practice in their homework, discussion, and quiz before they take an exam. And you'll see here, there's a little example of the polls. I was using Mentimeter this past year so that students could use their cell phones to answer poll questions. This can really work on whatever polling system works for you. I like this because you could get the live information. I want to say that the students really like this. I solicited early feedback from my students, and I got a lot of feedback that the students liked the poll questions, so they could check their understanding, and also that feedback also was that they really took well to this idea of, just because you don't get it right now doesn't mean you're not going to get it. So that's it. The other one that's really big, I think, in our physics classes is how to say yes to taking risks and trying new things. And I think, you know, sort of the gut check here is the statements about, my students can't do some specific skill unless I tell them exactly how to do it. And so this is one I run into a lot in labs. One of the things that is challenging is that as instructors, we kind of forget what it's like to think like our students. So we think our students know how to think like we do. In lab in particular, we kind of assume that they have a lot of the habits that we do, or maybe because they're habits, they've kind of faded into the background for us and we don't notice them anything. But also then we put our students in these positions where the stakes are high and they have to get things right the first time, because there's not time to cover everything and give space for mistakes. So what's the space here? Why do we ask students to figure things out? I'm going to just put out here, this is kind of a stronghold of Western education, especially when we want them to figure things out to be exactly the certain way that they should be. I think that in STEM, we really hold strongly to the idea of, like, we can only ask questions that have right answers. And there are other kinds of questions we can be asking. So why are students quiet? Well, a lot of the time they're afraid of being wrong, either because of shame or because grading. And, you know, maybe we're not giving them time to think when we ask them to try something new. So how do we balance this? This is really gets into a lot of the research work that I've done, but there's a lot of power to balancing innovation with skill development, and actually innovating early and innovating often. And this is going to have to be nonlinear. So if we that means that early on, we're going to have to slow down. We're going to have to value troubleshooting and reflection. But as students build their skills, build a habit of trying things, they actually get faster and faster and more effective. So why do we ask students to invent early and often? Like I was saying, they get used to dealing with new situations, which is something that if we keep telling students what to do, they're never going to learn how to like get the confidence and get the habit to just try. I usually don't like to talk about just doing things in physics and in learning, but sometimes you do just have to try. And I want to say it feels like you can't ask students to invent early because what if they don't get the right answer? And there's research that actually shows that students can benefit from trying even if they don't reach a canonical solution. The idea here is that by tangling with a problem, students actually develop useful forms of prior knowledge so that they can kind of anchor their learning and understand more completely the problem that they're dealing with and why, the canonical solution is a good solution. So as far as how this looks in lab activities, I'll bring some of the ones we've been using at Illinois as an example. This is from I would say kind of the first real lab that we do with our mechanics students, both algebra and calculus based. And what we ask them to do is to use the IO lab, which has a wheel encoder in it, so it can collect data on its position, velocity, and acceleration. We just ask them to look at it rolling up and down a ramp and to test the claim that the acceleration is the same on the way up as it is on the way down. And this is pretty well defined in the sense that they know what sensor to use, they know what action they're doing and what claim they're testing, but we actually leave 3 key points of innovation here. One is interpreting the data. And this is new to students. So identifying going up and going down in the midst of all the other things going on is not trivial. And acceleration graphs are difficult to interpret. So that's the first innovation that they have to do. And they have to try and they have to explain how they know. The second thing is deciding what different and same mean without prior experience doing this. And so this is an interesting case where the two values are not identical, but they're close. So students have to come up with a way to balance between these details. And then, of course, because our students also come up through the Western education, most of our students come up through the Western educational system, they're also tangling with this idea of what do you really expect from me? So students who enter labs in particular expect that when we give them a claim, it's going to have to be true. Labs prove that claims are true and that we're going to grade them by getting the right answer. And a lot of labs do this. But what we do is, for example, if they do really find that these values are different, even though that might not be what they expected, we actually we encourage them to tangle with this question of, do I trust my data or do I trust my expectations? And with our grading system, we reinforce our values. So we use a rubric system. And the first time students are trying this, we give them feedback up to the top level, but what you'll notice is that they don't actually have to master a new skill the first time to get full credit. So we can give them feedback without penalizing them as they're learning. So this is sort of one of the ways this can play out. I certainly am not perfect at it, and there are a lot of things that I'm trying to rethink as well. But what I want to advocate, especially for this innovation approach, is that students who innovate develop habits to make decisions and take risks in good, productive ways. They develop a toolbox of skills that are more flexible and that persist through the semester. So if they figure it out once, they remember it next time. And it also gives us an opportunity to give our students insight into community standards and practices in kind of a nature of science, culture of science sort of discussion. And students notice they're better at dealing with challenges. So, we've surveyed our students about their confidence about how they can encounter a problem and come up with a way to solve it, come up with a plan for it. And we've seen that there's been a shift. In general, students after practicing this feel more confident about dealing with new problems. And this is reflected in their conversation, in their feedback, their written feedback as well, with statements like, I used to panic when I faced challenges, but then I learned that challenges are normal. And learning to run with the best idea, but not the perfect idea, or really getting this idea of getting better at noticing challenges as they come up and fixing them. So there really is this sort of like increase in confidence and increase in the ability to get stuff done. So kind of putting it all together, this is the framework that I propose, which is to notice sort of the no's and the discomfort, figure out what that discomfort is coming from, what we value, and then figure out how to keep those values in a space that gives students more respect and more agency. And so that is kind of the end of the slides that I have. And what I would love to do is to start a conversation about what are the no's in our classes that we could turn into yes. And I'm not saying that we have to solve everything today, but maybe getting more specific, I would love to talk about what are teaching practices that you've heard about, or maybe that you even tried that your gut reaction was, I can't use that in my class. I'd love to interrogate that, like to try to do this, like, why not? What would it cost us? And, like, what do we value here? For example, if you hear, oh, like I just give my students this lab to do and I don't tell them, all the details about how to do it. Well, okay, we could talk about that. Or, perhaps an extreme example when I'm trying to tangle with myself is ungrading. What if I let my students set their own grades at the end of the semester? Right? It's weird. I'd like to actually embrace this discomfort and see what we can do as a group to sort of move ourselves forward and see if there are opportunities to kind of change things up. So, like I said, that is the presentation part that I have. I'd love to, open up the conversation.
Actually, there's been one question that's in the chat from a bit ago that was about, as your students are engaging with Mentimeter, are you tracking their participation at all, or are you just getting a broad kind of view of what's going on?
I did last semester because pandemic. Is that I used it as a bonus point for the class. So I wanted to encourage students to participate synchronously, whether they were in person or online. And so I basically had a point where they could say, I'm here. And if they said that they were there, they got a bonus point for the lecture. So there was no penalty for missing it, but it wasn't graded on correctness. It was just, were you here? And I don't love taking attendance, but as someone who sometimes struggles with executive function, I know that it can be helpful to have structure, little incentives to get you in the room and get you logged on, because I definitely would have been the student who'd have been like, I don't have to go to this lecture. I'll just watch it later. And then like just before the exam, stay up all night watching all the lectures.
So Cindy, I see you have a comment, and if there's anyone else, please, you can put your question in the text, the chat, and I'll read it out, or you can start participating and ask yourself.
Well, I have two comments, actually. One was about the last thing you put up about the self-grading, and many of you have heard this before. I know Mark has heard it. I've been doing self-grading of homeworks in my classical mechanics class now for 4 years. And the results have been absolutely outstanding. They've learned more. I've learned more about what they don't understand. So they basically do the assignment and then they have access to my solutions. And so even if they get, like, if there's 10 problems and they get 3 of them done and they get nowhere on all the others, if they can at least identify where they get stuck and then why they got stuck and what the proper solution is, they can get a 3 out of 3 or a 4 out of 4, and it's been fantastic. So that's one thing I've done that's really worked. But the other thing is, I am very careful when I talk about class participation to tell my students that class participation does not only mean I ask a question and you raise your hand and you give the right answer. I said class participation can come from giving an incorrect answer. You're still participating. It can also come from commenting on an answer that another student gave that maybe you didn't understand, or maybe you want to clarify, or maybe you want to ask a question about that student's answer. So I make class participation I think what you're talking about, it's non-threatening. It's really doesn't just boil down to I've got the right answer. And then I'll be quiet in a second, but I had an amazing experience in my classical mechanics class, and I posted in there about it makes you have to also be vulnerable if you're going to do this. So we were doing rising motion with air resistance, and we were discussing whether or not, obviously the one with air resistance doesn't go as high as the one with air resistance. But we were talking about, let's suppose there's a height that they both get to. Which one takes longer to get to that point? And honestly, I did not have a complete answer in my mind. I wasn't 100% sure. And I had students who explained why the one with air resistance would get there first and give reasons, and a batch of others who explained the complete opposite. So I had to be vulnerable for this, because in the end, I had to say, I need to think about this more, because you've all raised some really, really good points. So I just wanted to throw that out there, because I just had it today. And, am I going to sit down now and try to figure it out? Maybe, maybe not. Maybe I'll leave it up to them as extra credit if someone wants to come up with a explanation, or if someone wants to program it or whatever, or prove it or whatever. But so anyway, I resonate very well with what you said, Catherine.
I love hearing about that. That's so cool. What course size do you teach?
Well, right now I'm teaching classical mechanics, and I have 11 students in each. When I teach intro, I also tend to have small classes, which is nice, somewhere between 12 and 15 in a section. So I'm lucky with that. I've been here long enough that I can put some restrictions like this on. I've deliberately limited them because of pedagogical reasons. Mm-hmm. And when I have a class of 24, that's all our room can hold. But even if I have 24, I don't get the same, back and forth and interaction and group work and things like that with them. So my class sizes do tend to be on the small side. So, but even a course like classical mechanics, if you have 45 students in that class, if you're at a big university and it's a sophomore level class, you could still do this self-grading. It's, it's incredible, and it doesn't take me any more time than what I was doing before. So, yeah, and the feedback from the students has been extremely positive, which I think, Mark, you can attest to this, because you've seen me talk about this about 6 times.
I have, and because of this.
You're frozen.
We'll give him a sec, I guess.
You're frozen, Mark.
Am I back?
Yep.
Yeah, you're back now. You're saying because of.
Okay, I'm back now. I was saying because of our conversations, all of my students in my quantum mechanics class.
And how's it working?
And they also enjoy it. It's going very well.
Although it's funny, some of them find reflecting on their work to be harder than doing the problem sets themselves. And they complain that that's the hardest part of the homework is when I make them grade their own paper and reflect on what they learned.
Right. Well, I have a colleague who tried this in an upper level Astro course. And one of the things she said is that students, and my 400 students have been through this with me, and no one has ever said that the self-grading is onerous. And she's had a few that said it takes too much of their time to grade their own work. And what I said to her was, maybe you need to tell them not to work on one problem for 4.5 hours. Yeah. If you're really banging your head on a quantum problem, after an hour, get help from the professor, get help from students, get help from whatever, or just stop and wait for the solution. So that helps a little bit. That may make it less onerous to them. I don't know.
The closest I've done to this in the large format class is using like entry and exit tickets or minute papers or what have you, where there's sort of 2 strategies that I use. One is for students to, I do a lot of things because I'm big on the vulnerability thing too, which is the double-edged sword. It's one of those funny things where I'm like actually being femme presenting. In some ways, I feel like there's this extra emotional burden, but I think in some ways it also makes like students more willing to like trust me a little more in some of the ways that we ask them to engage. But it's weird. But
But
I'll ask.
that can backfire
It
on
can.
females especially, because if a female says, I'm not sure about this or whatever, you get your student evaluations and you're
They
like,
say they don't know anything.
right.
Yeah.
Whereas men are assumed to be, we know this, men are
Yep.
assumed to be brilliant.
Yep.
So if they are a little bit vulnerable, it doesn't affect them as much. So, so it's a tough choice for female faculty, but I know it's the best for my students. So I'm just going to keep on doing it. So.
But yeah, in terms of the minute paper kind of thing, there's sort of two questions I end up asking that kind of are similar. I think one of them is, there are things in physics that like on their face are confusing. And I think many of us who have been around the classroom are like, oh, well, I know this is hard for students. Like, how is it that Newton's second law and Newton's third law are possible at the same time? Which, we're like, oh yeah, of course. But a lot of students get tricked up by that. And so one of the things I'll ask them is to deal with those kinds of questions in the minute paper, to be like, just try. We'll talk about it later. You don't have to get it right. Try answering one of these. Like, it's not a trick question, but it is a tricky question. And then the other thing I've asked them to do in these minute papers is to reflect on their understanding. But in particular, I'll ask them to write like notes to future themselves, like guides to say, like, write some tips for future you for 2 weeks from now for how you're going to remember this. And so I think that, is sort of related to this like reflection and bringing the students' selves and well-being into it.
So I have a question. You went through some of the types of questions that you use with Mentimeter and how the progression of those questions from answering as a group to then individuals answering for themselves and so on. We certainly, as a body of professionals, have access to hundreds and hundreds of clicker questions, right? So do you think using those questions as is, or do you think there's a necessity to evolve those in some way to fit the way they're posed or the way they're used?
I think the key is really being mindful about how you're using the questions and being transparent with the students about that. And that's part of the reason I said, like, I don't like to ask questions that surprise students by being wrong. To me, that is not, that's not a stance that I want to stand behind personally. Like, I don't want to create that kind of space in my classroom where I set students up to be wrong. But I understand that other people find it very useful to say, oh, I wasn't alone in getting this wrong. Actually, a lot of us are having a really hard time with this idea. So now let's get onto the, let's get it straightened out. So I think that it does take a mindful stance, though. I think it really does take going in and saying, this is the way that I want to frame my classroom and the space that I want to set up. And so maybe almost what I feel like needs to go along with it is documentation or training or something more about the framing of these kinds of tasks.
Katie, I like that when creating a yes space. Yeah, one of the things I thought about was that I do just that, but I follow it up with, I ask them lots of questions. I find where I don't expect them to know the answer, but that's exactly what I tell them. No, it's okay. There's no wrong answer. I know I haven't given you the information for this yet. Let's just see what you're thinking. And in that regard, then they're more willing. But I feel I need to say that.
I love that. And I imagine that like it takes a few weeks for them to get used to it, right? And then they start answering more often.
Oh,
I don't know. You tell me.
Yeah, it takes a while.
I mean, I'm just thinking with the labs, it takes about 6 weeks for them to really get into it.
Like parenting, you have to be persistent and consistent.
Absolutely. But like parenting, the relationship evolves, which is very rewarding.
Sorry, I have to go to another meeting that started 15 minutes ago, but I put in the chat If anybody wants more info on the self-grading, feel free to email me. Thanks very much, Catherine.
I have a question about the self-grading that came up earlier. This is just one of the techniques you've been talking about. We've been thinking about peer grading, but in the lab that seems difficult and we haven't figured out how to implement. I like the idea of self-grading, because the idea that you don't give students like a rubric to grade their work, you just ask them to reflect on like, where did I go wrong, and what was that about? That seems productive. Is that the self-grading idea, or describe that for me more if you could?
So I confess that I put it out there as something that I am just starting to think about, because I really wanted to, like I said, like some of these ideas, it's like, I feel a little uncomfortable. And this is one that I'm still tangling with that. So as far as self-grading, I mean, I confess that the way that I approach lab reports, which are more like lab memos, is for students to like talk about that stuff as part of what they report. Is like, oh, this was really kind of hard, or we had a problem with this, or we're not sure about these results, they seem weird, which is not the same thing as what you're asking about. I don't know, like I would love to do some kind of like a peer review related thing for the lab, just because there's so much, right? Because there's this kind of backdoor enculturation that happens in the lab of like, this is what it's like to be part of a scientific community. And if we do have the goal of modeling like physics scientific community, like peer review is actually a really big deal. I'm thinking of, there's a grad student at, I want to say Washington State, who had a PERC paper that was partially about like VR lab stuff, but then the other half of the paper, they actually within their labs had, they like had to write like proposals for equipment and like review each other's proposals. And I should try to find the link for that and put it in the chat, because that to me was like a really powerful way to, and then like people like got equipment. I mean, I think it was easier with the VR to be like, oh, you can get this code module. And yeah, I think there's a lot of models for it that already exist. I haven't played with it. I want to, but I haven't had a chance to play with it.
Yeah, the peer review I think is something that we would really like to do, but we also haven't cracked that enough. We haven't really gone out and tried to see what people have done either. But regarding your excellent talk, I liked it very much. One of the things that I'm trying to do is, we've shifted focus since the pandemic to a lot of other things, and it's really pushed our labs forward, I think. But we're rebuilding now. It's like a rebuilding year for the team. We're reorganizing things, and so the labs are not as smooth as they used to be. But I think they're better. And one of the things we've been focusing on is doing an analysis of the data and making sure that when we ask students questions in the lab, that they're using the data they actually have instead of the theory that they know is right. And what we've noticed in this transition is that even when we ask them to specifically to draw on their data, they will give us the theory answer. And I think it's all, as you say, because students have this expectation that they'll be graded on their correctness instead of their lab experience. And we just want them to reflect on that lab experience, and to have that moment of doing the actual thing. So something I do is that, and it's not working out, is why I'm bringing this up. So I have written, the 5-page how to do data analysis, supplemental material that I give to all my students and no one ever reads. And then I tell them, you do whatever you want. Just tell me what you're doing. If I don't understand your uncertainty estimates, I'm going to be mad, but it's not because they're wrong. It's because you didn't explain. If you tell me it's 10 times bigger than I think it should be, and you have a reason, great. You get full credit for doing that. And if you tell me that, you came to the conclusion using this method, I might tell you what's wrong with that, but I'm not going to give your points off. But if you just give me the answer and I don't understand, that's what I'm looking for. And neither seems to be working. They won't read the complex, they won't teach themselves the complex skill that I want them to learn, and they won't just introspect a little about their thinking and expose it so that I can help them.
Yeah. I'm wondering, so in terms of like the complicated, like the data analysis, like are they also trying to do a pretty complicated experiment on top of that?
I don't think so.
Okay.
All of our data analysis is like, how good does the line fit, which I think is
not trivial, actually.
Right. Yes, that's very true. Yeah, I think all of our labs, make a line. And
okay.
How well does it fit? That's basically what the analysis comes down to.
Yeah, I wonder. So, I mean, I don't want to be like, oh, I'm going to troubleshoot your labs. But one of the things that I found is really helpful when I feel so two things that I'm hearing is one is sort of the like, how do I get them on board with the skills without like, just blasting them with instructions. And then the other one is like, how do I address this whole expectations thing, which goes long and deep and is, it's wild. There's psychological there's also really interesting nature of science implications because there are these underlying ideas that people develop that like somehow there's like this like real true physics underneath all the mess. It's wild. But I digress. Yeah. So what I have found is helpful, and I have not 100% solved labs, right? Like what does that even mean? But I found that it's really helpful if there's a skill I want students to learn to really take time to focus on that skill without worrying about getting all the other stuff done. And so I've used pre-labs for that. So pre-labs are a really powerful tool for me to give students a chance to explore just one thing so that when they come, this is this innovation and then future learning, future instruction. And so they can like explore, try to get a sense of what you need to pay attention to. Attention is a big one as experts that we don't even notice because we just say, oh, well, you just look over there. So that might be something that you might consider is if there is sort of some kind of task they could do that would highlight, why it might be important. Like, with linear fits, what are they called? There's this like example of like 4 different data sets, and one of them's like a dinosaur or something that like all of them have the same average and the same like R squared and
love it.
Yeah. So there might be something in there to try like with some variations that would highlight the important features.
Yeah, I like that. We split off 2, we wasted. See, I mean, even I am saying it, right? And this is my idea. We took 2 labs at the beginning of the year and spent them, not wasted them. We spent that time doing this work, the skill that we want them to do. And then so in the next term, all I'm getting is the lab didn't say to do this. And, I'm thinking how often, do I have to keep this up? And I think it's more the expectation, really, that they come into lab with a preconception of what should be going on. And I have not yet broken this, concept,
Yeah. Yeah. The other thing that I found is really powerful so the expectation that like claims are always true. Sometimes I will give them claims that they know are not going to be true.
Oh.
That can be one. The other thing that I've had a lot of success with is really borderline cases where the model like talking about models and how like the equations that we give them really are models and they make assumptions. So I actually, full disclosure, I borrow very heavily from ISLE for like thinking about how to frame experiments, and I get a lot of head nods. I love ISLE. I should have given Eugenia so many shout outs because she was the first person to be like, stop telling your students what to do. Just let them do something and see they will come up with something good. So full shout out to Eugenia Ekina. But yeah, I think they're like borderline cases are really fruitful. I think like part of it is breaking this idea of like, there is an outcome you're supposed to get. And it's really hard to find that in a physics lab and set up a lab. And so there are I'm going to call it cute. It's not really cute. Like, I'm not trying to be demeaning, but like there are twists that you can do on the kind of prompts that you ask. So, you know, claim testing is a pretty powerful one where, you know, maybe you give them a claim that like they're probably going to find isn't true, but like the point they had to get credit, they actually have to like give you evidence, which is kind of what you're saying,
Right.
you know, and then there is some wielding our power there of like, I'm going to grade you on, what am I grading you on? Your what you say at the end or what you say all the way through and the continuity. But yeah, I think those borderline cases also give a really nice, I cut Mark off. They give a really nice opportunity to say like, this thing almost gets us there, but then there's more. And maybe that's the next thing coming in the curriculum, or like with the example lab I'd shown, they hadn't really done friction yet. So they expected the acceleration to be the same, but it was actually a really nice launching pad to say, oh, there's something more happening here. So some thoughts.
Well, as a just to jump in, the idea of having a lab centered around a claim, would an example of that be the mass of a pendulum is related, dictates the period?
That one, it depends on if they have learned about pendulums yet. Pendulums are tricky. Actually, there's a paper about that too. I know that Natasha Holmes, her group has a paper about questionable behaviors of students doing a pendulum lab and how they throw out data and they fudge things because they know what answer they're supposed to get. But like a framing that I've tried with that is to say the model will break down. Find where it breaks down, or find where your experiment is precise enough to be sure that it's breaking down. It's real twisty. It's twisty, but it's like really saying like, we care about the equipment, we care about precision, and the model breaks down. Like already I've told you what the answer is that you'll find. You just don't know where you'll find it.
So I really like these claim testing labs. I do one in first semester labs on coefficient of restitution, where the students drop, racquetballs basically, and I give them 2 or 3 hypotheses that eminent scientists have come up with, and they have to show or disprove those hypotheses. And they get to kind of design the labs. I encourage them to look at physics teacher articles on coefficient of restitution. There's several of them out there, so it kind of draws in a number of different skills, and it's a fun lab to do. There are a lot of different ways that they try to approach it. I also wanted to comment on the peer grading in the lab. We started trying that right before the pandemic, 2019 fall. And I think it has some real promise. We kind of shut it down during the pandemic and haven't gotten it started up again. But there's a really good book called Composing Science by Leslie Atkins and Kim Jackson. And they talk about peer grading and things like peer review of each other's notebooks in the lab, and then the students are able to make corrections in their notebooks before they submit them, which was a really cool idea, and the students seemed to like it. We gave them a little bit of time at the beginning of the lab to do this, so it wasn't outside, it wasn't terribly burdensome, and I think the students appreciated being able to get points back on the lab, right? They kind of went through the rubrics and helped each other. And I'm looking forward to getting back to that hopefully next year. But it seems to work pretty well.
Cool. I just posted the link to the website in the chat since there were questions about it. I also love Leslie, so I could imagine, that this would be wonderful.
Mention a broader thing I'm getting out of all this. Without getting into the specifics of labs, peer grading, self-reflection, claim questions, evidence, what I'm hearing is to make it a yes space, we kind of have to be explicit about what we're expecting. We have to explain our expectations to the students. Correct me if I'm wrong, or provide a rubric or model it to them first so that they feel comfortable knowing It's okay not just having the one and only what you think correct answer. So it's okay to fail. It's okay to struggle. It's okay to, wait. Everybody, my entire life is just it was based on my end result. And now you're telling me it's not. And we just have to get them comfortable with otherwise.
Agree. Yeah. And I think that what you're saying is right. It's what are the constraints that we place? Because it's not that yes spaces are yes to everything. It's in this space, everything is yes, or, something like that. So I think, what you're reflecting is like, here are the ways that we constrain the space to make it so that everything can be yes in it.
Well, I hate to jump in and end our conversation, but we're coming to the end of our scheduled time. And this is a great opportunity to continue to make use of communities, which is you can continue to post questions about this in communities and continue the conversation on there too. Or if there's others that didn't get a chance to watch live today, this will be recorded and they too can continue to participate in the conversation. So I'd like to thank our host. I think it was a great conversation, really engaging, lots of great resources shared in the chat from everyone. Thank you so much. I hope I'm not being bad here, but Devin, can I put you on the spot? Our next coffee hour host is here. So I thought I would just throw it over to her and give her 30 seconds to pitch why you should come 2 weeks, come back and listen to her.
Yeah, thank you, Mark. You should absolutely come back in 2 weeks because it is the Tuesday. You get 2/22/22 on a Tuesday. It's very exciting.
Wow,
So
that in and of itself
if you're
is
not
worth coming for.
celebrating already, come hang out at our talk. And I think Katie did a great job sort of segueing into what I'll be speaking about with getting comfortable in the classroom with things that are uncomfortable. I specifically work with introducing quantum mechanics and quantum computing in elementary school classrooms, which is an entirely different way of thinking and doing science with these students. And I'll be introducing our process for developing these activities and some of the more recent results that we've seen over the past few years, introducing quantum to third graders.
So back in 2 weeks, learn about sporks, my favorite quantum example. I use it now. I heard you talk about it, and now sporks are the way. Sporks are my path. So, all right.
Sweet,
Thank you, everybody.
Sporks and jelly beans.
Yeah, that's it. Sporks. Thank you, everybody. And thanks again to our host.